Hello and welcome to everyone. So we'll continue the last class in which we have discussed about the event study analysis. So in the last class we have discussed that what is event study analysis and the different steps of that. Then we have calculated the normal return. So we have discussed that there are the different methods to calculate the normal return. Now we'll discuss about the abnormal return. So what is the abnormal return? Abnormal return is basically the deviation of the actual return from the expected return. Here the expected return is nothing but about it is a normal return. So the abnormal return is nothing but the deviation from the expected return or the normal return. So let us say here this is the actual return of this is this is the actual return of the asset I at time t, and this is the expected return of the asset I at time t. Then the difference between this actual return and the expected return is nothing, the abnormal return. Now, however, what we assume here that we are calculating abnormal return for a particular asset for a particular day. But when we are assuming an event window, we assume that there will be certain period, certain days over which the effect of event we wanted to observe, we wanted to calculate. So we have assumed a event window here. In that window, we have more than 1 days. Now, if it is more than 1 day, in that case, this particular here, when you are assuming that abnormal return of asset I at particular date t, it is not necessary or it is not reasonable to assume that this return will be same across all the day. It could be different in 1 day and different at the other day. So in that case, what we do that to calculate the abnormal return, we have the concept of cumulative abnormal return. So cumulative abnormal returns is basically nothing but the measures the aggregated abnormal return over the event window. So here we are aggregating it over the event window starting from T1 to T2 for asset I. So this CAR shows cumulative abnormal returns of asset I for the event window from T1 to T2. Next, there is the other way to calculate the abnormal return is that if there is more than one asset or firms, return could be varied across the asset or the firms. So let us say if you wanted to find out or you wanted to study multiple firms for a particular event. In that case, for a particular firm or asset I, the same day at time t, return could be R1. On the other hand, for the asset different, let us say this is firm A or the asset 1, then for the asset 2 at the same time, same day, the return could be different. So which one we should choose? So for that what we do, we take the average abnormal returns. So we do not pick or choose any asset, rather than we take the average of all the abnormal returns of all the assets of all the firms. So that's what we call average abnormal returns. So this is AART 1 upon n, I up 1 from n. So therefore, this average abnormal return will be associated with not any individual asset or individual firm, rather than it will be for a particular day. So that's what we calculate average abnormal returns. Then the another concept that we have, cumulative average abnormal returns. Again, we have calculated this average abnormal returns for all the assets I belonging to this particular study sample for a particular day at time t. However, we know that in case of event window, we have more than 1 day. that is, it starts from here and it goes here. And this average abnormal return belongs to a particular t. And we also know that it is not reasonably appropriate to assume that the same return will be repeated on the next day. It could be or it could not be the same. Then in that case, what we are doing, we are aggregating all the average abnormal returns up for the whole event window. That's what we do here and known as the cumulative average abnormal returns, and it is calculated using this particular formula. So, once we have calculated both normal and abnormal returns, so we have discussed how we calculate the normal returns, then we have discussed various methods to calculate the abnormal returns. So, once we do that, the next is we wanted to see, is there any difference between the abnormal returns and the actual returns? Are they the abnormal returns are statistically significant? So, basically we go to the hypothesis testing. Hypothesis testing framework is usually set up to make decision. So, here we have the null and alternative hypothesis. Usually the null hypothesis, we assume that event does not has any impact. If the events does not have any impact, that means abnormal returns should be equal to 0. That's what we have here. Event has no impact on returns, which imply that no abnormal mean returns or unusual return volatility if we are concerned about the volatility. However, we are here concerned about the return, so we are basically concerned about that there is no abnormal returns. That means the value of abnormal returns is equal to 0. So, in that, so what here the null hypothesis will be any calculation of abnormal returns, whether abnormal returns of asset I for particular time t, it will be 0. Whereas the alternate hypothesis will be this abnormal returns of asset I at time t is not equal to 0. So, now if we are accepting the null, that means there is no impact of the event on the asset return, or if you are rejecting this null, thereby implying that yes, there is the impact of the events on the asset returns. Now, to test that, we have the two approaches, what we call the parametric test and the non-parametric test. In the parametric test, usually we use the traditional t statistics or the sum of the variance of the t statistics. In case of non-parametric tests, we do not use any traditional statistics, rather than it is the free of any specific assumption about the return distribution. So, in that we have the two tests, that is the sign and rank test. So, in general approach to create the test statistics is that, see, basically let me go back here. So, when we have to make the decision about the null hypothesis and the alternate hypothesis, we need certain kind of test statistics, and using as the criteria, we decide whether we should accept the null or whether we should reject the null. So, here the basic discussion is that how we should formulate this t statistics. So, to formulate this test statistics, we have the two approach, one the parametric, another is non-parametric. So, here we are talking about a parametric test and the general framework. So, the parametric test, what is the general framework? The first, we have to estimate the variance of the abnormal returns. Why? Because we wanted to go to test the validity of the abnormal return. So, we need the variance of that particular abnormal returns. Then, using that estimated variance, we calculate the test statistics. So, what is the formula to calculate the test statistics? The formula is that estimated abnormal returns that divided by the standard deviation of the abnormal returns. Then we use this test statistic to calculate, to reject or accept the null. So, let us take the few example here. So, first we are taking the abnormal return. So, here the abnormal return ARIT, which we have discussed how we calculate. If we use this, the test statistics will be asymptotically normally distributed as the length of the estimation window, that is the event window, increases. So, as the event window increases, this will follow a normal distribution with mean 0 and variance sigma square ARIT. So, is the variance of the how we calculate the variance. So, in this particular case, how we calculate the variance of the residuals from the market model, then this will be this. Now, what is this abnormal return? Abnormal return was the difference between actual return minus expected return. And we have seen that how we calculate the expected return, there are the two approach. One was the constant mean return, another was the market model. Now, here if we are using the market model to calculate the expected return, in that case, the standard deviation of the abnormal return will have this particular structure, that it will be 1 upon t minus 2 t 2 upon t, where UIT square is the estimated error term, which we have in formula we have represented with IT. So, the estimated value of eta IT, here we have U hat IT square. So, the variance of the ARIT will be this. This you can recall, in the OLS you have studied that this YT is equal to alpha plus beta xt plus ut. The estimated value you have yt hat equal to alpha hat plus beta hat t plus ut hat. And there we have discussed the variance of this sigma hat square was 1 upon n minus 2 summation of n from 2 to n and this ut hat square. The same formula we are using here, because the structure of this also was a linear regression, like the linear regression model. So, once we estimate the variance, we will be able to obviously calculate the standard deviation of this. Then, using the standard deviation, we can formulate the test statistic of this, where this ARIT hat, it is known as the standardized abnormal return. Now, we have this test statistic we have calculated. Now, using this test statistics, either we will reject the null or we will accept the null. So, how we make that decision? If this calculated test statistics if it is more than at a certain percentage of confidence interval, if it is more level of significance, if it is more than the tabulated value, that means it is significant, and then we reject the null. However, if this test statistics which we calculate, it is following the normal distribution, so therefore will from where we will get the tabulated value, we will get from the normal distribution or the t distribution, we can say. Test statistics, if it is less than the tabulated value, then we will accept the null. Now, when we reject the null, it implies that event does not have impact. If we accept, event does have impact if we accept the null, that means event does not have impact. Now, in terms of market efficiency, what we can say by looking this result, if you are able to reject the null, that means market is inefficient. However, if you are accepting the null, that means market is efficient. So, this is the one example we have taken. So, we can take another example of the abnormal return. For example, here we are calculating the cumulative abnormal return. So, this, and for this we can calculate the variance of this using this particular formula, which is basically nothing but the sum of the individual daily variances over the days inclusive of T1 and T2. So, this is the basically we are doing summation of that. So, once we calculate the variance, then again using the same formula, this, that is the cumulative abnormal return divided by the standard deviation of the cumulative abnormal return, we can formulate the test statistics. Then using the same procedure, using this particular test statistics, we can make the decision whether we are accepting the null or we are rejecting the null. If you are accepting the null, that means there is no impact of the event. If you are rejecting the null, that means there is the impact of the event. In terms of market efficiency, what we can conclude, if there is no impact, that means market is efficient. It has immediately processed the information included into the price. However, if there is the lag, if there is the impact we have, that means market is inefficient. So, that is not reflected into the normal return. Then there is a certain issue we have with this event studies. So, similarly we can choose any abnormal return and we have to find out the variance or standard deviation of the particular, and we use the similar formula to calculate the test statistics for other abnormal returns. Now, there is a certain issue we face in the event studies. First, the cross-sectional dependence. So, right now what we have assumed that every asset is independent. So, while calculating the return of the one asset, we have not taken consideration its interdependence with each other. However, that is not true. There is the interdependency. There might be the interdependency among the assets, among the firms. In that case, the calculation of the returns would be misleading. Why? Because we have assumed that covariance is 0. However, there is covariance is not 0 when there is the interdependency. So, if that is the case, then what is the way out we have? So, there are the two way out. First, we should not aggregate the assets or the firms, rather than we should test for the individual assets, then aggregate those results and make the decision based on that. We generalize those results, or what we can do, combine those assets and make a portfolio, then evaluate the portfolio rather than evaluating the individual firms. So, there are the two way out we can choose depending on the objective of the work. Another issue what we have, changing variances of the returns. Right now what we have assumed that the variance of the returns remains same across the event over the time. However, if the events are the variances are not same, in that case the variance of abnormal returns will be too low. If it is too low, that means we can frequently reject the null hypothesis. So, though in the reality there might not be impact of the event on the asset prices. However, due to the miscalculation of this or the wrong assumption of the constant variance, we can get the result, yes, there is the impact. So, what is the way out of this? So, the one of the solution is suggests estimating the variances of the abnormal returns by implying the cross sectional variance of the returns across the firms during the event window. So, this you might recall that how we have estimated the variance of the abnormal return by in cumulative case we have aggregated, we have summed up the variances of the all the individual assets. In case of abnormal return, we have taken it from the estimated error terms. However, we have not taken consideration of the correlation between these two. So, if that is the case, then the suggestion is that the variances of the abnormal returns should be calculated using the cross sectional variance of the returns across firms, and there should not be test for the no separate test for each firms and no equal weights to stocks. So, rather than giving the same weight, we can give the different weights to the different firms or the assets. So, that could possibly solve this particular issue. Then, if you remember that in the beginning we have talked, in the previous lecture we have discussed that event study could be done for the short horizon or it could be done for the long horizon. The long horizon, also known as the long event window. And there we have discussed, then when we are considering the short and long, there is the little difference while calculating the abnormal return. So, in case of long event window, this cumulative abnormal returns we can calculate, or we can use the buy and hold abnormal returns. What is that? So, there is the difference between these two. What is the difference we have? In the buy and hold abnormal returns, we imply the geometric returns rather than the arithmetic summation. So, in the cumulative abnormal returns, we sum up the abnormal returns from T1 to T2. However, in this case, we do not sum, rather than we take the geometric summation of that here. So, this BHAR, that is the buy and hold abnormal return, can allow for the compounding, whereas the CAR does not does that. So, here we calculate using this particular. So, instead of putting the summation here, we use the multiplicative or the geometric form we use here. So, where this ARIT is nothing but the abnormal returns which we have calculated. In case of CAR, we have added this from T1 to T2. Rather than adding here, we are multiplying that. So, that is the basically difference we have. So, in case of long term event, we usually go with the buy and hold abnormal return calculations. So, how we implement the event studies here? So, this is the general approach we can adopt. Combine all events into a panel like data set. So, that is for all the events here, let us say the 4 events we have. Now, let us say there are the 4 forms we have. So, every event for all the forms. So, this is the, let us say 3. So, these are the number of events, and this is for one particular firm or maybe from one particular asset. This is the second firm or second asset, and this is number of events we have. And similarly, here this is the number of events and maybe the third firm or asset we have. So, that is what we say here, combine all events into a panel like data set. So, we have combined all the events. Then estimate the normal returns, estimate the abnormal returns, and estimate the cumulative abnormal returns, and have the statistical test. Using the statistical test, then we can make the inference whether there is impact of the event or there is no impact of the event on the asset prices. Then in the long term event studies, what we do, analyze the impact of events over the extended period, several months to years, rather than focusing on the short term event window. So, why basically we do? To examine the enduring effects of the events on the asset prices or the firm performance, that is the long term effect, what is it is going to happen on that. Then to test the market efficiency over the long horizon and the different abnormal returns we use rather than the CAR. So, that is the basically what we have, the buy and hold abnormal returns we have, which already we have discussed here. That here this what we have the RMT, that is the benchmark return. Usually we take the market indexes here. Then the another aspect comes the calendar time portfolio method. So, construct a portfolio of assets on that event date and analyze their returns over a calendar months, and regress this model here where RPT is the portfolio return. So, basically what we are doing here, that on the event date we make a portfolio of assets. So, T is equal to 0, on the event day we make that, and we are analyzing the returns of all these assets of all these firms for a calendar month. So, over this calendar month we analyze the return of this portfolio, and then we use this particular formula here, that portfolio return, this alpha plus beta RMT into epsilon T. So, that is the we have a general approach of this. However, when we are including large number of firms into the sample, or we wanted to see that does the event has similar impact on all the firms, though those firms may vary on certain characteristics. For example, suppose if you wanted to examine does the event have a bigger impact on the smaller firms or it has a ability. For example, there was the demonetization. So, does it have a similar effect on the smaller firms, or it is have different firms on the smaller and the larger firms. So, if we have such kind of question and the object we wanted to find out those, then what we do, we calculate the abnormal return and treat those abnormal returns of every firm or every asset as the dependent variable. Then we identify the firm specific or the asset specific certain characteristics that may explain the variation into the abnormal returns. Then we use this particular structure for the linear regression here. So, here abnormal return of asset I, and these are the size of asset I, or we can say here if we are using the firm. So, then we can say this is the abnormal return of the firm I. Then the independent variable have included to characterize the certain aspects, for example, market capitalization, leverage ratio, or the industry dummy variable, which industry we have. So, we have included this here so that we can see does the size matters for the abnormal returns, or does the leverage, that is the debt to equity ratio, does it matter, or does the industry matters for the abnormal returns. So, that is what we call the event studies cross sectional analysis. So, a general form, so those are the specific characteristic behavior we have taken that could be generalized here, where we have ARI, that is the abnormal return of the firm I. Then these are the certain variable, characteristic variable we can take from J to M, and gamma measures the impact of the corresponding variable J, that is the characteristics on the abnormal return, and mu I is the n error term we have. Then in the beginning we have talked, we have the two approach, one the parametric method or the non-parametric test method. In the non-parametric methods are the statistical techniques that do not rely on the specific assumptions about the data distribution. If you may recall, so what we have assumed that this abnormal returns, they follow normal distribution with mean 0 and variance as AIT. That means here we have assumed, we have made an assumption, this abnormal returns follows a normal, a certain distribution here. However, in this case, non-parametric, we do not assume any such kind of assumption. In this category, we have the two tests, for example, sign test and the rank test. In case of sign test, what is the null hypothesis we have? Abnormal returns are equally likely to be positive or negative. Alternative hypothesis we have, abnormal returns are more likely to be positive or negative. So that is the effect we have assumed. So count the number of positive and the negative abnormal returns in the event window. So then the test statistic is S minus n upon t square root n upon 4, where S is the number of positive abnormal returns and n is the sample size. And based on this statistics, we can accept or reject the null hypothesis. Similarly, we have the rank test where no systematic pattern in the ranks of the abnormal return. So there is no systematic pattern, it does not follow any certain pattern here. So the rank the abnormal returns for each event, compute the average rank for event and the non-event periods, then test if the average ranks differ significantly. If differ significantly, that means there is the certain pattern. If there is the pattern, then that means there is the impact of that particular event we have. So that's all about the event study analysis, and it's a very interesting and useful methodology we have in the finance, where we have a lot of scope to examine the impact of any event, whether it's political, economic or macroeconomic, that does it have impact on the financial market or the asset or the evaluation of the firms. So we will see in a practical implementation, we will discuss about how we can implement those. Thank you so much being with me.